Hey, hello guys, welcome, vanakkam, vandanam, namaskaram. Wife here, Venkanan is here. So today we are going to see electrochemistry part 2. I hope last part was very clear cut and I have discussed literally every points in a very fast way. When I was seeing the duration of the video, even I was pretty shocked that it had taken around only 45 minutes, but I was planning to take it around for 1 hour. But okay, if it completes fast, then in that sense, it's good for me only. Wait, where is it? Electrochemistry. Here it is. Okay, so already we have written for 10 pages. 10 pages 45 means, okay, so that means I am the one who has written everything very fastly and I am the one who has explained very fastly. Okay, so that means in this video we are about to discuss from Nernst equation. Okay, so we are going to discuss Nernst equation, then after that equilibrium from constant Nernst equation, then also relation between EMF and the free energy, then electrolytic conductance, then after that we are having product of electrolysis. That one big thing is there, right? Electrolysis of sulfuric acid is there, strong electrolyte, weak electrolyte, Kirchhoff's law is there, then Oswald's dilution law is there. With that we will be completing. Okay, so till Oswald's dilution law we will be completing this video. So what shall we do? Shall we continue in this PDF itself? Okay. So since we have written 9 pages, that's enough. 9 is okay one. So then we will continue with the new page. This is useless. Okay, so as I said that we will be beginning with electrochemistry part 2, that is Nernst equation. With derivation we are going to see. Okay, so with derivation completely we are going to see Nernst equation. So where we will be using this Nernst equation, what is it? See, Nernst equation is used to calculate cell, okay, E cell, that is the EMF of the cell, okay, that is the voltage of the cell, that is the force that is given by the cell in order to move electrons, in order to produce electricity. Okay, so that is what we will be saying as Nernst equation. So to calculate this one only we will be saying it as Nernst equation. Okay, see, to calculate E cell we want to know that we have to know already E naught of the cell, and from this I will be giving you the derivation. First you will be checking out the formula. So we have to know that yes, so E cell is equal to E naught of the cell minus 0.059 whole divided by N, where N means number of Faradays. Okay, how many Faradays it has taken. So what is a Faraday? Faraday, we will be seeing that out. Okay, here even we will discuss. I don't know whether I have said, no, I have not said about Faraday in the last video. In this video even we will be seeing. Okay, last video was taken at March 4. Now it is around March 26. Okay, so into log of products whole divided by reactants. Okay, so log of products whole divided by reactants. Okay, so this is what the Nernst equation is. Now we shall see how this equation actually came. Well, it may look like a very complicated one, okay, but believe me, once you have done just 2 sums, this equation will be your pet. Okay, very, 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 very easy. I'm not saying that since I'm a topper in chemistry, I'm not a topper in chemistry. Maybe I was once upon a time. Now it's all decreasing. I'm again trying to get this ability. Okay, back to the story of chemistry, not to the story of mine. My Soka Vehicle at all will be said in a separate video. Since you have subscribed, you have no other choice. Okay, so first of all, we will be checking about reaction quotient. Already we have seen in thermodynamics of 11th. Well, I haven't uploaded any videos for 11th because I'm not that strong in thermodynamics. But anyways, so since we have studied thermodynamics in 11th standard, we know that reaction quotient. For example, I'm going to consider a reaction like this. Okay, so where A plus B, it's going to be unequilibrium reaction. Okay, irreversible reaction, where it gives C plus D. Okay, so the concentrations are going to be, what are the concentrations? X, y. Okay, so since these are concentrations, it will be preferred if it is written in another color. Okay, so it is x, y, l, and then n. Okay, so now coming back to here, what is reaction quotient? Reaction quotient is represented as q. So q is equal to products by reactants. Okay, so what are products? C into D whole divided by A into B. So what is C? C is L. What is D? D is N. So here it is X, and then here it is Y. This is what in 11th standard, in right corner of a page. Don't think like I have remembered everything from 11th standard that I'm saying it's in the right corner. I'm saying because some incidents happened with that thermodynamics in that particular lesson. That is why I can remember. There it would have been given in a very big way. Okay, the sentences will be around 5 to 6 lines, I think. And it was very tough for me to read. I couldn't even understand everything in the beginning. But later, okay, it was very easy. Okay, so this is what reaction quotient is. Okay, so we know that. This I will write in which color shall we choose. Okay, so yeah, we know that delta G is equal to delta G naught plus RT ln Q. ln Q is actually natural logarithm, I think. Yeah, natural logarithm into Q, which is reaction coefficient. Okay, so this is something we have studied in class 11th itself, and if you are asking the derivation for this, I'm so sorry, neither do I know, and it is not asked in 12th standard board examinations, so we will continue with it. Okay, so delta G is equal to negative NFE naught. Okay, NFE, sorry, just NFE. It is equal to, where delta G is equal to, this is also something you have to know. These are extra formulas. Delta G is equal to negative NFE. Then comma, delta G naught is equal to negative NFE naught. Okay, so these are those things that you have to remember. Okay, so now if you are just substituting it over here, then that means minus NFE is equal to minus NFE naught, okay, plus RT ln Q, okay, plus RT ln Q. So this is what you have got. Okay, so see, NF is there, right? So what I can do, I can divide this NF. Okay, so dividing this NF. So that means what you will be getting, so this term and then this term will be cancelled out. So here there will be dividing, NF will be there. Okay, so minus E is equal to minus E naught. So we can even divide minus NF. Okay, so we can divide minus NF. Okay, so minus NF. So here will be plus, here also will be plus. Okay, plus E naught minus RT ln Q whole divided by NF. So this plus or this minus had gone here. Okay. So from here, what you have to do is you have to focus in that particular point. Okay, this point which I'm erasing, right? So here only you have to focus a lot. Okay, because just see, here we have got E, here we have got E naught. Still, only you have to change this particular term. If you are able to change this particular term into this particular term, then you will be getting this equation, right? Okay. So hereafter, I'm just going to focus on that particular part. That means, see, what is R? R is a constant. Okay, I think it's known as Rydberg's constant, which if you just put the value, which should be 8.314. Okay, 14 is my favorite number. Joule into kilo inverse mole inverse. Okay, so this is what R's value is equal to. Okay, then after that T will be always constant. Okay, it will be either 25 degrees Celsius, 25 degrees Celsius, or 298 Kelvin. Okay, or 298 Kelvin. Okay, mostly Kelvin is preferred because Kelvin is what the SI unit is. So we will erase this 25 degrees Celsius and just 298 Kelvin is okay. Next is F is there, right? That F is Faraday. Okay, this is number of Faradays. NF is actually number of Faradays, where F is Faraday. What is a Faraday? Faraday is the SI unit of capacitance. Okay, it is the SI unit of capacitance. If you want to know its definition, Faraday is equal to 1 Faraday. Okay, 1 Faraday is equal to 1 mole of electrons. 1 mole of electrons into charge of electrons. Okay, into charge of electrons. If you are doing it approximately, very approximately, for easy calculation purpose, it would have been given as 96,500. Okay, it would have been given as 96,500 coulombs. Okay, well, physics you would have studied. I would have taught all these things as seminar. Okay, where along with this coulombs I would have written also a microfarad, millifarad, not megafarad, that's completely wrong. Micro, milli, nano. All these with SI units I've written, right? The same thing mainly, but in physics I did not say any definition like 1 mole of electrons into charge of electrons. Here I've said it in a very clear way. Okay, so these are those values. Then N is number. Okay, so L and Q can be written as so coming to this point, okay, which can be also said as 96,500. It is not the exact value. Here I've written approximately. The very exact value according to NCRT, okay, according to NCRT is I think 96,487 is what they have given as very approx value. Okay, 96,487 is what they have given as a very approximate value. Not approximate, very accurate value. But in reality, coming to reality, the exact value is 96,495. Okay, 495 is the exact value in reality, but in NCRT it is given as 96,487, which is a mistake, but you have to choose this NCRT value only. If they are asking you what's the value, then you have to choose 96,487 only. Do not make a mistake by choosing the correct value, okay, because we are following whatever it is in the NCRT. So even though if there is a mistake, you have to write whatever is there in NCRT, okay. So L and Q, which can be written as 2.303 into log of Q, okay, into log of Q. Like that you can easily get. Okay, so if you're writing like this, so these are those values that you have to change. So if you're changing it, then at last, if you're changing and if you're just substituting, and at last if you're simplifying, then you will be able to get that. Then you will be able to get that. RT, L and Q whole divided by NF is equal to, I'm not going to simplify all these values. I'm not that good at simplifying. Okay, so then you will be getting 0.059 whole divided by N into log Q. Okay, N into log Q. So this is the value that we are be getting. Okay, super amazing, done. So at last this value is what you are going to get in this place, so you will be getting this one. Okay, so here I have written Q, right, but here it is products by reactants, where here it is products, okay, and here it is reactants. Amongst this, which is having power, that means which is not having the concentration as 1. Other than that, you can take everything. So if in case here M value is 1 and here X value is 1, you can just neglect those two values, and other than that you can take this CL and then this C to the power of L and then this B to the power of Y. Those two values can be considered. Okay, so this is what Nernst equation is. And note that Nernst equation is applicable one and only at constant temperature. Okay, so with different temperatures, we cannot use Nernst equation. There is another equation that I'll be saying to you. So at standard conditions, okay, at standard pressure, at standard temperature, then so at standard molarity and concentrations, right? So at standard conditions only you are allowed to use this equation. Okay. So after this, what we are having perfect, we have completed one page. Then in case of Daniel cell, so that means here is where applications point or application thing starts. And today I think I'm not that good in looks. I saw myself in the mirror a little bit dissatisfied. Okay, so coming back to here, Daniel cell. Since I kept oil. Okay, so Daniel cell. Oh god, spelling. So what is this equation going to be? It's going to be Cu2 plus Zn gives rise to Zn2 plus plus so Cu. Note this, always here in this side which is being reduced, here this is what being reduced. Okay, this is what being oxidized. Okay, perfect, packard and all right, super. So for this what you are going to do? Write the same equation. That's going to be, see first what is E naught value? E naught value, this alone I know in my mind. Oh god, my head. E naught cell. I was looking like Chota Bhim it seems. Okay, is equal to 1.1 voltage. Okay, so is equal to 1.1 voltage. This is something that I have already said to you all in the first episode itself. Part. A lot of Netflix is doing. Okay, so after that, so what's going on with this one, which is equal to E naught cell minus, if my hair is looking like Chota Bhim, neglect it, okay, because sometimes Koga is also seen by me, 0.059 whole divided by N into log of products whole divided by reactants. Okay, so E naught value is equal to 1.1 minus 0.059 whole divided by N. See, 2 is what they write. So what you have to do, you have to take only 2 as its value. Okay, so 2 into log of, what is the concentration of here? Whatever concentration of zinc that they have given in the question that you can use it, zinc 2 plus whole divided by concentration of reactants in sense Cu 2 plus. Okay. And already I have explained in one of my, no, not in this video, chemical kinematics I have said that. Not yet, that is being uploaded. Okay, it will be uploaded very soon. So yeah, so one of this, the square bracket actually represents what? It represents the concentration. So that only you have to remember. From 10th standard we are using the square bracket, I think, I don't know, 10th or 11th, but I came to know that the square bracket represents concentration from 10th standard only. If you know at very beginning, then very good, super, amazing, keep it. Okay. So this is something. Then after this, what else we are having? Okay. So here, what I'm going to do is, I'm going to give you, what's that? IUPAC. Okay. International Union of something. Okay. So that representation, and we are going to do. So where nickel, Ni2 plus. This IUPAC is kind of my enemy, you know, giving every rule in chemistry. But since that is father of enemy, I cannot accept it. See, father of chemistry, I cannot accept it. That I hate it. Every time I ask some sort of doubt in the rule, then they will be saying that it is said by IUPAC. It is said by IUPAC. Okay, so coming to here, this is what the oxidation part is, this is what the reduction part is. That we have seen, right? Okay, so that means, first I'll write the equation. So Ni plus Ag plus gives rise to Ni2 plus Ag. Okay, so here what do you think the N value is going to be? Always remember, even though here there is 1, okay, here there is 2 plus, you have to take only 2 plus. Okay, you have to take only 2 plus. You cannot take 1 plus. That's wrong if you are taking it. Do you know why I'm erasing it again? Even though after marking it, I'm reading every video for one shot video. Every thing for one shot videos. Okay, so this one we have got right. Perfect. just substitute over here. The value, I don't know what is the value for this reaction. I cannot remember for every reaction, but for this reaction it is 1.1. That I know very well. Okay, so I can just substitute over here. What can I substitute? I'll write here even since it is just one step. Pass on. It's going to be E naught cell, sorry, E naught cell, E naught cell minus 0.0591 by 2 into log of what is the concentration of products, Ni2 plus, okay, so whole divided by Ag plus. Okay, so this is with the formula that you are going to use. Actually, I think I said something wrong. One second, I'll confirm it. Yeah, I did do a mistake. Okay, so that mistake is that I said that Nernst equation will be used only in standard conditions, right? I said it exactly opposite. Nernst equation will be used only in non-standard conditions, whereas E naught of the cell, wherever you are seeing E naught, the not right, wherever you are seeing not right, in that case, okay, wherever not is there, that only will be used in the standard conditions. But whereas when you are seeing a formula without not, then that means it is not used in the standard conditions. Also in physics, we are using epsilon naught, right? Because it is used in the standard air condition. Okay, so E naught will be always used in the non-standard conditions. That means temperature is not constant, it can be any temperature, volume can be anything, so like that. So this is what you are going to use over here. Like that, for equations you can easily prepare and you can keep so that in the examination you can do, but if you ask me, that's completely waste. Just in examination, just what 1 second will it take to write this. So next is, there is sum, that is actually example 2.1, but I'm not going to do any sums. Okay, so after that, equilibrium constant for Nernst equation. I do know that there is no editing, and that's one of the foremost reason why my videos are taking 45 minutes, 1 hour, that much of time. But I'm pretty sure that it will be going to your subconscious mind whenever you are seeing me writing, and also whenever you are writing, whenever you are copying it. And it's a seminar, as I said. Okay. See, first we are going to consider an equation. Okay. So from this, what is this equilibrium constant for this Nernst equation? See, what we are going to see is we are going to calculate Q, that is this equilibrium quotient is there, right? This equilibrium quotient, this is what they write. This equilibrium quotient is what we are going to calculate from Nernst equation. How are we going to do it? Very simple. From this, I'm going to transpose everything towards this side. Where in that case, whenever I'm transposing this one towards this side, what I have to do is I have to keep this E cell as 0. Okay, so I have to keep this E cell as 0. So after keeping the Z cell as 0, then if I'm transposing all these two over that side, then this will be remaining right in this side. There I have to put inverse log. Okay, so then after putting inverse log, then I will be getting only this term. Where this term is what known as Kc, or also known as equilibrium quotient. Okay, or also known as Q. So then we will be getting it. This is what we will be saying. Okay. Equilibrium constant from Nernst equation also you can write, or for Nernst equation also you can write. Okay, so I'm going to do it with an example where Daniel cell only I'm going to take. So Daniel cell, whenever you are hearing the word called as Daniel cell, then even you have to fix in your brain that the equation is going to be what? Okay, the equation is going to be the same equation only. We are going, as I said, that it's going to be done, or it's going to be said in millions of times. All you have to remember is that Cu2 plus in this side and Zn2 plus in that side. Okay, Cu2 plus is in this side, Zn2 plus in this side. That's it. Okay. So I'm going to use this one. Okay, this one I'm going to use. This one I'm going to take. Okay, or maybe I can also substitute 1.1. No, 1.1 is not substituted. Okay, so what they have given us, they have given a very small sum. We shall first see that sum, then we will come over here. Okay, ma. So first, this is not a sum, this is an exemplar model, so that you can understand remaining models. So take this one. Okay, so take this one, which is this equation. Then what it will be, E naught cell, okay, is equal to what, 1.1 minus 0.0591 also they have given in some cases, and I think somewhere I've seen instead of 1.4 also, but just 0.059 is enough. Okay, into log of products, okay, which is in place of products we are having zinc 2 plus whole divided by copper 2 plus. Okay, ma. So in this place, what I'm going to do is I'm going to consider this E naught cell as 0. Okay, so that means if it is being considered as 0, then I will write it as like this. Okay, like this it can be written, right? Okay, so I'm transposing this to here, this total part to over here. So if I'm transposing this total part to here, then that means I can write it as 0.059 whole divided by 2 into log of zinc 2 plus whole divided by copper 2 plus is equal to what? Is equal to 1.1. Okay, so if you want, I can put this to here and this to the denominator. If I'm putting that to the denominator and this to there, then it will be Zn2 plus whole divided by copper 2 plus is equal to 2.2 whole divided by 0.059 by 1 into log inverse. Okay. Also, I think it can be a log inverse. What is log inverse? Is equal to 10 to the power. Okay, 10 to the power. That means it's exponential form. It can be written, right? I don't know that much of function video. If I'm uploading, then I will be strong in that also. Okay, so like this, you can write it out. So shortening the size. Okay, well, I don't think I can do anything in this place. Okay, so I'm going to jump into the next. Instead of being as a cheap steak, okay, this is good. So next one is that a general form. Okay, well, log Kc is equal to yeah, so that's it. If in case they have given the value, that log Kc, see here, log Kc, where is this log Kc? This log, this is what known as Kc. Zinc 2 plus by Cu2 plus is there, right? So that is what known as Kc. So here log Kc is equal to what? E naught of the cell, which is 1.1. Okay, divide by, yeah, so whatever I written, right? So this is there, right? Yeah, that one. So if I just simplify this value, okay, in terms of log even we'll keep it as, no need of log inverse, log Kc even we'll keep it as. Okay, so this term is known as log Kc. Okay, if it is being kept as log Kc, then what I can do, just transpose this and this to that side, so that means log Kc is equal to E naught of the cell, even I'll keep it as E naught of the cell into 2 whole divided by 0.0591. Okay, this is actually general, this is very general, Okay, extremely general. This formula you can use for everything. Okay, this is what the formula for equilibrium for constant Nernst equation. That is what I was trying to express here. But since from here even I can write. Okay, so since from here even I can write. Right? So I have written over here. So for an example, if you are doing for in this case, so which means it should be 1.1, which can be said as 1.1 into 2 whole divided by 0.0591. Okay, so yeah, if I just divide it, how it will be? It will be 220 whole divided by 5 or 3. Okay, so the final value I'll write. Okay, since the handwriting is not that much visible, it can be written as 37.28. So that means it will not be 5, it is 3, I think. Okay, so this is what we are going to get, 37.28, 37.28, and this is what the formula. This is what the main formula is that I was trying to do. Okay. So then the next thing. Okay, we have completed already these many pages. Relation between EMF and free energy we are going to check. Also with derivation. Ayyo Sami. So, what we have to prove is, we have to prove that delta, this color values, are, okay, so delta R G is equal to negative of N F E. Okay, so negative of NFE naught. So this is what I have to prove over here. So how will I prove it? How will I prove it? Very simple. We already know this formula. From where do we know? See, here even I have expressed this. But how? Okay, so it's not how. There are only a few sums. Maybe we can do a few sums based on calculating n values. This one is what the formula is. Okay, sorry, I said there is derivation. Well, derivation I will upload in a very soon. If there is a derivation. Okay, because in book it is given as lines only. Okay, in lines, according to lines, even we can easily understand that this is what the formula is. But you can also apply over there not. Okay, you can also apply over there not. There is no problem over there. Okay. So there is no derivation. Yeah. If there is derivation, I'll definitely upload in upcoming videos. Or I'll try to attach with this video even, since I know some more editing, if I don't get scoldings from my parents. So yeah, Zatin, I'm going to consider this is not Daniel's equation. No, this is not. Zatin Cu2 plus gives rise to Zatin2 plus C. This is Daniel cell. This is also Daniel cell only. Yeah, correctly. Okay. So since here Cu2 plus K, I got confused. Sorry. Okay. So this is again Daniel cell only. As I said, that we'll be using this Daniel cell everywhere. Cu2 plus over here. Okay. Zn2 plus over here. How shall we remember it? Copper. Right side. R. Right. So R is there, right? To both of them. Zinc. It is light. It's a light voice. Pronunciation sound, right? So also left is also likewise only. So like that you can remember copper right, this one this side when you are facing towards the camera. Okay, so I've got this equation. From this one I'm going to find n values. Okay, so this is just some problems to find n values, number of Faradays. How many is there? Already I've said that it is going to be only 1. Okay, so n is equal to, sorry, 2. N is equal to 2, right? Okay. So if I just get another sum, then in that case, how will they happen? Finding n. So how will be n for an example if I just take, but in case of 2zn, okay, plus 2cu 2 plus 2zn 2 plus 2c, okay. In this case, what you will be doing, see, totally how many Cus are there that you have to count. See, what is Faraday? Faraday is the amount of electrons, sorry, amount of energy that is required to remove an electron, you can say, or that is the amount of energy that is required to give an electron also, you can say. See, totally how many Qs are there, Cus are there, Cu1 and then Cu2 is also there. Okay, so when you add these two only, you will be getting 2Cu, right? So that means for this one it is 2 plus, for this one also it is 2 plus. So that means for this Cu, 2 Faradays are required. For this Cu also 2 Faradays are required. So totally for this Cu, 4 Faradays will be required. 4 Faradays will be required. So same case for Zn also. Same case of Zn also. To convert 1 Zn to Zn2 plus, you want 2 Faradays. So to convert 2 Zn2 plus, then you want 2 into 2, which is 4. Or 2 plus 2, or 2 plus 2 only, not into 2 plus 2 only, which is actually 4. Both are same only, but there is some difference in terms of meaning. Okay, so 4. So that is why here n is equal to 4. Like this, you can remember. Okay. So after this, electrolytic conductance we can see. Wow, very soon, right? The time is flowing just like anything. Okay. So electrolytic conductance is like what? Okay, so this 7 I will do in the next page. Electrolytic conductance. So electrolytic conductance is there. Then product of electrolysis is there. Then Kirchhoff's law is there. I think already I've said Kirchhoff's law. Also, Oswald's dilution law is also there. First is resistance. Okay, so what is the general formula for resistance? Resistance is equal to, well, we all know, right? Venkatesh Iyer, that is what normally, or vegetarians are Iyers, that is also a sentence. Well, already this is very simple, mainly V is equal to IR. If you haven't seen the video of what current electricity, okay, there I have uploaded everything very in detail, starting from the derivation of 2 marks of this formula and also till to the 3 marks. Every bit I'll explain in a very clear cut way. If you want, I'll be giving you the link in the description if I remember. Okay, yeah. So V is equal to IR. You can just check it out in that video. I'm not going to explain in this one. Okay, so units is equal to, what are the units? Units are ohms. Units are what? Ohms. Ohm is the unit. Okay, but yeah, it should be pronounced as but many of us are pronouncing it ohm. OHM. No, pronunciation is correct only, but they are all thinking the ohm sound, but it is not actually ohm sound, it is sound. A lot of people takes it wrongly. So this is what they say unit. Next is conductance. Wait, I will first write all these terms. Conductance is there, resistivity is there, resistivity. Conductivity is also there. So what is conductance? Conductance is actually 1 by R. This is actually see, R is equal to V by I, right? R is equal to V by I. Here, conductance is represented as G. The conductance is represented as G. Here it is represented as R. Here it is represented as rho. Here it is represented as K. I don't know why, but a lot of terms are represented by K only. Conductivity or specific conductivity is represented by K. Okay. So conductance. What is the SI unit of conductance? Conductance can be said as, in book also they have given SI units, right? That also you follow. If you don't know what page number we are in page number 41. Yeah, so the electric resistance is represented by symbol R and it is measured as ohm, which in terms of SI base units is equal to kilogram meter square, or also known as Simon square into area square. Okay, which in terms of SI unit. Okay, so not only ohm, SI units are also equal to. Okay, so the SI units are also equal to. So what are the SI units? Okay, SI units are also equal to Simon cube. Simon cube area square, or also equal to kilogram meter square. Okay, kilogram meter square. Well, there are some specific explanations for this also, derivations also. Well, I have given only the formula for this SI unit. Okay, there will be different formulas, right, for resistance like that. There is actually a formula for resistance which is ML by something. ML by something is there. Okay, where based on that only this SI unit came, I think. There is also different derivations. There are different derivations. Okay, so next one is coming to conductance. What is this conductance? We can say that conductance where G is equal to I by V, right? Okay. It is equal to G is equal to 1 by R. So if R is equal to V by I, so which means I by V is its formula. I by V is its formula. Okay, so I can also write that this G is so the SI units of G. What are the SI units of G? SI units of G is over. So Simon minus 3, area minus 2, or kilogram inverse meter minus 2, or what is it? Ohm inverse. Okay, ohm inverse. Next is resistivity. Resistivity is equal to R is equal to rho L by A. So resistivity is equal to resistance into area by length. So its SI unit is going to be, what is its SI unit is going to be? Resistivity, right? So it is going to be ohm meter. Ohm meter. That's it. That's what the difference is. I think it's literally ideally white. Okay, it is known as ohm meter. Well, in some places it is also said as ohm centimeter, but yeah, ohm meter is what the SI unit is. Always remember to write in SI units. Okay, always remember to write in SI units. Do not make a mistake. Okay, so I made one time in my examination paper. So for that I've got half mark deducted. Okay, and here conductivity, which is K. K means kappa. Greek word. It is a Greek word. Kappa. Yampa. Okay, so this is kappa. Where conductivity, which is actually represented as K, can be said as 1 by rho. Yeah, is equal to 1 by rho. it is exact opposite. Okay, it is actually exact reciprocal of resistivity. So which can be also said as, we know that rho is equal to R into area by length. So kappa is equal to length whole divided by R by A. Okay, so from this, these two I'm going to take. These two and in this one. Okay, so 1 by R. Okay, what is 1 by R? 1 by R is equal to G, right? Conductance, which is G. 1 by R is equal to G. 1 by R is equal to G. L by A I'm going to take it as G naught. So kappa is equal to G into G naught. Note that 1 by R is equal to G, comma L by A is equal to G naught. Okay, so these are those. If you want, you can take a screenshot. For this, you can take a screenshot. For this, you can take a screenshot. As there isn't that much. For this, you can take a screenshot. For this, also you can take a screenshot. I really don't have time to start a group and to upload all these as PDFs. I'm not that much, patient. Yeah, the SI unit of kappa is ohm inverse. SI units. What are the SI units? SI units are ohm inverse into centimeter inverse. Okay. Next is cell constant. That is what? Yeah, cell constant. What is cell constant? This is what known as cell constant. This is what known as cell constant. Okay, which is ideal. It cannot be changed, right? Yeah. The vessel of a cell cannot be changed. Okay, so after this we are having molar conductivity, then equivalent conductivity, where only one concept will be doubtful in this one. Now I'm just checking when will this all complete, since my leg starts to pain within this moment. So molar conductivity. Then also we are having equivalent conductivity. What is this molar conductivity and then this equivalent conductivity? Very simple. Molar conductivity is the conductivity per unit mole. Okay, conductivity per unit mole. Well, a lot of people, I'm saying a lot of people, including me, are thinking that if molarity increases, okay, if the concentration increases, then automatically conductivity will also increase. But this is wrong. Because if molarity increases, then the conductivity will decrease, which is exactly opposite. Okay, it will decrease. It will start to decrease. It is because, for an example, if this is a tub, I can say, okay, not that much is required, that much. Okay, so in this, what I'm going to keep? I'm going to keep a concentrated solution, right? And also here I'm going to keep a diluted solution. Here, that means a lot of ions will be produced. Here, less ions only will be produced. Yeah, so that's correct only. Whenever ions are produced a lot, the current will be produced high. Whenever ions are produced a little bit less, okay, it's produced less, then automatically current will be also produced less only. That is actually okay, applicable, because ions are those which determine the current. But the thing is, here since ions are produced a lot, there will be collisions. Okay, there will be collisions. A lot of collisions will be taking place. But since here ions are produced in a very less way, so that means there won't be that much collision. Okay, little bit of less collision will be there will be like this. Okay, a lot of collisions will be there. So that here, totally we are just taking out, the conductivity will be very less because of collisions. But here, conductivity will be very high, set by my chemistry sir. So remember this point. Well, every point is set by my teachers only. I don't know why did I just specify that one point. So, yeah. This can be represented as, okay, this can be represented as like this, or also this term around can be represented as mu. You have to know that the difference between this and in this. This is small lambda, whereas this is capital lambda. Yes, this is small and then this is capital. Okay, so this is small and then this is capital. Small and then capital. Okay, if a solution is dissolved, then you can use this one. Okay, this is something where it is this is undissolved, for undissolved. This is for dissolved. Okay, so this is something you have to remember. Already I have become tired. I'm going to take a 15 minutes of rest after this one. You can also take, which is actually defined as the conductance of all the ions produced by 1 mole of electrolyte present in the given volume of solution. Okay. So the conductance of all the ions produced by 1 mole of electrolyte that is present in the given volume of solution. So this one is what used to represent this molar conductivity is equal to K conductivity into volume. Okay, K conductivity into volume. Well, volume can be represented in terms of concentration, which means K into 1000. Conductivity into 1000 whole divided by molarity. So this is something you have to know, and the concentration is mole per liter. Sorry, SI unit is mole per liter. SI unit is ohm inverse centimeter square mole inverse. Ohm inverse centimeter square liter inverse. Okay, so this is right. Okay, so with this, how are we going to represent same small lambda or this lambda but here it is going to be EQ, here also it is going to be EQ. Okay, so here it is. It is defined as the conductance of all the ions produced by 1 gram equivalent of electrolyte in the given mass of the solution. The one and only difference is that by 1 mole of electrolyte instead of that, what you are going to write? You are going to write 1 gram of 1 gram equivalent. Okay, 1 gram equivalent. So yeah, 1 gram equivalent. The conductance of all the ions that are produced produced by 1 gram equivalent 1 gram equivalent of electrolyte in the given volume of solution. In the given volume of solution. So what's its formula going to be? Lambda EQ is equal to K into 1000 whole divided by normality. Okay, so this is what their formulas are. Okay, so what is its SI unit going to be? SI units are going to be ohm inverse, okay, centimeter square, EQ inverse. Okay, here molarity, so it came, here normality, so EQ, okay, came. Okay, so here in this space we are going to see their their common parallel points and in their relationships. First is here what you have written 1 mole. What you have written 1 gram equivalent. This is what the conversion is. Okay, so then after that what you have written? Now their formula relation. Okay, formula relation. That is normality is equal to molarity into NF. Okay, into N factor. Okay, into N factor. That means normality. If you just multiply to this molar conductivity, its N factor. Sorry, divide with its N factor. Okay, with its N factor. Then automatically it will be equal to conductivity of equivalence conductivity. Okay, equivalence conductivity. Okay, so after 15 minutes of break we will start.